Welcome everyone. My name is Sadar Sudi Muhammad, mathematics teacher. Today we will learn about quadratic equation. So at the end of this lesson, you'll be able to define quadratic equation. Also, you'll be able to complete the square of a quadratic expression, but also you'll be able to solve quadratic equations by using completing the square methods. Before we proceed further, please let us have a simple activity. Please observe the chart here. We're going to provide a chart that contains quadratic expressions, coefficients of the quadratic expression, as well as the constant terms, but also we have other terms, which is b over 2a and b over 2a whole thing square, and we have the last expression said x plus b over 2a the whole thing square. So please let us check the table. Okay, so now this is our table as explained earlier. The table contains quadratic expressions, and as you can see here, but also you have the constant terms a, b, and c, and other terms, which is b over 2a, b over 2a square, and x plus b over 2a the whole square. So now let's suppose to use example number 1 here is displayed from the table, so as we can fill the gaps here completed from the charts from the table. So now let's check example number 1 here. The expression says x squared plus 5x plus 25 over 4. So can you tell us what is the value of a here? Yes, you can see that the value of a here is 1, because a is the coefficient of x squared, and the coefficient of x squared here is only 1 there. Now b, of course, b, coefficient of x, which is 5, and c, it is 25 over 4. If you compare the expression above, general, and this one, you can see that c is 25 over 4. So now what is b over 2a? b over 2a, as we said, b is 5, and 2a, so a is 1, so it is 5 over 2. What about b over 2a square? That is the square of this one here, which is 25 over 4, and the last expression is x plus b over 2a square. So, and that is x plus 5 over 2 the whole thing square. So now let us check this number 2, question number 2, or expression number 2, which says x squared minus 6x plus 9. Who can tell us the value of a from this expression, x squared minus 6x plus 9? What is the value of a here, a coefficient of the x squared here? Yes, nice, very good. The value of a here is 1, so it is 1. And what about value of b? Yes, good. The value of b here is minus 6, so it is minus 6. What about value of c? Yes, the value of c, if you compare this expression with the general expression of quadratic equation, it is 9. So the value of c here is 9. Yes, so now it is b over 2a. We're supposed to fill the value of b over 2a. So b is minus 6. It is minus 6. That is b minus 6. over 2 times 1. So it is negative 3 over, it is negative 3, equal 6 over 2, that is. So here, b over 2a gonna be negative 3. Good. Now it is the square of this one. So negative 3 square, which is 9. And finally, we have the expression says x plus b over 2a, which is negative 3. So plus minus, that is minus. So it is x minus 3 whole thing square. Good. Now let's come to expression number 2, which is x squared minus 16x plus 64. What's the value of a here? Yes? Come on. It is 1. Yes, the value of a here is 1. The value of b. The value of b here, it is negative 16. Whether the x here is missing, but it is negative 16. Negative 16. What about c? Yes, c is 64. 64. So now it is b over 2a. B is negative 16. So negative 16 over 2, which is equal to, because a is 1, so 2 times 1 is 2. This is equal to negative 8. So here it is negative 8. And here is the square of the value here, which is 64. And finally, we have the expression x plus b over 2a, which is equal to negative 8. So x negative 8, the whole thing squared. Now we have the last expression here, question number 4. The value of a, it is 1. And the b, yes, the value of b is negative 3 over 2. Negative 3 out of 2. C, of course, c is 9 over 16. 9 over 16. So now it is b over 2a. b over 2a. So b is what? b is negative 3 over 2. Then divide by 2a. Divide by 2 times 1. So almost this is equal to negative 3 over 4. Okay? So this is equal to negative 3 over 4. Because b is negative 3 over 2, and over 2, which is this one, and a is 1. So it is negative 3 over 4. Then here is just the square of this, which is 9 out of 16. 9 out of 16. And finally, it is our expression which says x plus b over 2a squared. So this comes as it is, x plus b over 2a, this one, which is negative. So we have to put negative there. Let us put negative, because plus minus is always minus. And b over 2a, that is negative 3 over 4. But this thing squared. So now, we have completed the table here by just filling the missing gaps for a, b, c, b over 2a, b over 2a squared, and x plus b over 2a, the whole thing square. So now, my dear viewers and students, from this table here, from what we have done here, what observation have you made? If you try to observe the table carefully, especially the values and the expression there, do you see any kind of relationship? Can you see anything from the table? Please check it clearly and then give us the answer. Okay, very good. Oh, yes. Let's find persons here first. Who has seen anything, any observation marked from the table? If you try to look the values from A, B, C, B over 2A, B over 2A, the whole thing square, and the last expression is x plus B over 2A, the whole thing square. Have you seen anything in relation? Anything that maybe they seem to have some kind of relationship? Yes, very good. From the table, we have observed that from each expression here, C, the value of C is equal to the value of B out of 2A, the whole thing squared. If you come from expression number 1, the value of C is equal to 25 over 4. And the value of B over 2A square is the same, 25 over 4. If you come to question number 2, the same thing. 9, 64, 64. 9 over 16, we have 9 over 16. So this is the relationship that we have established, that for any quadratic expression, the value of C should be equal to B out of 2A, the whole thing squared. Therefore, if we want to complete the square of any quadratic, if you want to make a perfect square for a certain quadratic expression, then we can use this one, B over 2A square instead of C, to make it a perfect square. And this value, C equal to B over 2A square, this B over 2A square can be used to help us to build a perfect square, or to make a perfect square of a certain quadratic expression which is not a perfect square. For example, let us take the first expression there, which is general expression of a quadratic equation. Said ax squared plus bx plus c. This one. And let's say this is equal to 0. That is equal to 0. So, we can see that ax squared plus bx plus c, which is b over 2a, the whole thing square, this is equal to 0. Now, this expression is a perfect square. Okay, so from here, x squared plus bx plus, we said c, from those expressions here, it is found that c is equal to b over 2a, the whole thing squared. So as we said, x squared plus bx plus b over 2a, the whole thing squared, is equal to 0. Now this expression is a perfect square. How? Because this expression is the same as writing a into brackets x plus b out of 2a, the whole thing square, which is equal to 0. So this one is the same as this one. That's why we say perfect square, because if this is the factors of the quadratic, then we're going to have x is equal to negative b over 2a, which is perfect square. So if you try to expand, you're going to have the same value here, a x squared, then you have x times b over 2a, b over 2a times x, which is xb. It is xb over a, because 2 and 2 is already gone, because a half plus a half is 1. So then plus b squared over 4a squared. If you multiply it out, you're going to have x squared plus bx plus b out of 2a the whole thing squared. So now this is a perfect square expression. So from here, we have what have we learned? We have learned that if you want to make a quadratic expression to be a perfect square, if you want to make any quadratic expression to be a perfect square, we are supposed to add b over 2a square in both sides to make it what? To make it a quadratic, make it a perfect square. So that method of making a quadratic expression to be a perfect square is what we call completing the square. Because once the expression given was not completing that, was not a perfect square, so you are completing it to make a perfect square. So this method of making a perfect square is called completing the square. And here is what we're supposed to do here. We want to solve some quadratic expression by using the completing square methods. Let's see example now. The example says, what must be added to x squared plus 10x to make the expression a perfect square? What must be added to x squared plus 10x to make the expression a perfect square? Okay. Solution. Do you remember what we said earlier? Yes. To make a perfect square, to make an expression to be a perfect square, we are supposed to add b out of 2a square to that expression. So now let's go and see. From our example here, it says x squared plus 10x. This is our quadratic expression. So from here, what is a? A is equal to 1. Good. A is equal to 1. What about b? Yes, b is equal to, b is equal to 5. No, sorry, b is equal to 10. Good. This is b, and here there is 1, which is a. And b are the coefficients, a for the x squared and b for the x. So now from here, what are we supposed to do, as we said, is to add to this expression d over 2a whole thing square to make it a perfect. Okay? So d over 2a is equal to how much? 10 over 2 times 1, which is only 2. So 10 over 2, this is equal to 5. Now, we're supposed to add 5 square throughout or to this expression to make it a perfect square. So x squared plus 10x plus 5 squared. X squared plus 10x plus 5 squared. And this is the same as x squared plus 10x plus 25. X squared plus 10x plus 25. So now this expression is a perfect square. That expression is a perfect square. And this is the same as writing x plus 5, the whole thing square. Is what we said, this is a perfect square. If you open the bracket here, you're going to have x squared plus 5x plus 5x, which is 10x plus 5 squared, which is 25. So now the value of x here is negative 5. So this is a perfect square. So we are supposed to add 25. So therefore, we are supposed to add 25 to the x squared plus 10x to make it a perfect. Okay, so to make this expression a perfect square, we are just supposed to add 25, because 25 is the value of b over 2a. b over 2a, but whole thing what? Square is equal to 5 square. This is equal to 25. Are we together? Yes. Very good. Now let's check another example. Example number 2. We can solve this quadratic equation by using that method, which is completing the square method. Okay, solution. Good. Let's take our equation that says x squared plus 5x minus 14, this is equal to 0. Okay? So first of all, remember, we are supposed to have only this part, the part with coefficients. Okay? So we have to rearrange the equation so as we can only have x squared plus 5x at one side, and the number is constant to another side. Okay, let's go. So what can we do here? Okay, we have to add by 14 throughout. So this is going to be x squared plus 5x is equal to 14. Yes. So now from here, what is b? What is a? A is equal to 1. Good. And b is equal to 5. B is equal to 5. Okay. So, as we said earlier, to make a quadratic expression or equation to be a perfect, what are we supposed to do? Yes? Wow, very good. We are supposed to add to the expression or to that equation b over 2a squared. But first, let us find this b out of 2a. So b out of 2a here gonna be equal to 5 over 2. Due to that, b out of 2a square, this is going to be 25 out of 4. 25 out of 4. So now let us add this value, which is 25 over 4, throughout, okay, or in both sides. This is our equation, says x squared plus 5x is equal to 14. So now add 25 over 4 both sides. So it's going to be x squared plus 5x plus 25 over 4 is equal to 14 plus 25 over 4. That the rule of mathematics, whatever you do in the left, you're supposed to do the same thing on the right. So now, here we have already made this expression, which is ax squared plus bx, into a perfect square. And this is the same as x plus what? Plus 5 over 2, the whole thing square. If you still remember from what we have done from the first table provided. So this is the same as writing x plus 5 over 2, the whole thing square. If you expand it, it's going to be x squared, then 5 over 2, then another 5 over 2, which is equal to 1, so 5x, and this squared 25 over 4. So this is going to be equal to, then you have to find the LCM here, which is 4. In 4, how many ones? There are 4 1s, there are 1 4s, then that times 14. In 4, how many ones? There are 4 1s, then 4 times 14, gonna be 16, and 4 times 1 is 4, and that one it's 56. So this plus what? Plus 25. So here we have x plus 5 over 2, the whole thing square, equal to 6 plus 5, it is 11, carry 1, 5 plus 2, 7, that one is 8, so that is 81 over 4. So now what we need here, we're just finding the value of x, because we have been told you to solve the equation. To solve it means to find the value of x. So now we have the square and the value. So what to do here, we're supposed to produce the square root throughout or in both sides to get the value of x here only. Okay, so let us use this side here so as to make the other side as our reference. Okay, now we have here, so we have to square, we have to produce square roots. So produce square root square root in both sides. So this means square root of x plus 5 out of 2 square is equal to square root, which is plus or minus, of 81 out of 4. Okay? So probably square and the square root is the reciprocal to each other. So this and this gonna cancel. And what I'm going to have here, we are going to have, okay, so here I'm going to have what? Only x plus 5 out of 2 is equal to plus or minus and square root of 81, which is 9, over square root of 4, which is 2. So what we need is only x. So x is equal to minus 5 out of 2 plus or minus 9 out of 2. If you want on x, we are supposed to take away 5 over 2 in both sides. In which here, if we take away 5 over 2, it will remain on x plus 0, which is x. Then x is equal to negative 5 plus 9, negative 5 plus 9, how much? 4, yes, good. It will be 4 over 2, or x is equal to negative 5, negative 9. Negative 5, negative 9, which is how much? Negative 14 out of 2. So therefore x is equal to 2 to the 2, or x is equal to negative 14 over 2, which is negative 7. Negative 7. So this is our answer. So therefore, the value of x from this equation is either 2 or negative 7. As you know that a quadratic equation must have 2 values of x when you solve it. Is it clear? Okay, these are the questions to be done by you at your take-home assignment. And here is the end of our lesson. I hope you have enjoyed it. Until next time, bye-bye.